Hello everyone. In the last video, we had learned how to use the 7-segment display, how to display numbers, how to display alphabets, although we didn't display alphabets, but we know how to do it. Okay, as promised, the next video was supposed to be multiplexing. Multiplexing means you need to use multiple of these display devices. Now, the problem with multiple display devices would be that one display device would need at least 7 or 8 of these pins, and there are not enough pins available and not enough digital pins available. Although I could use analog pins also for this, but what about the third one then? What about the fourth one? So, normally a clock would require 4 of these digits, right? Now, how would we do that then? Okay, so let's learn how to multiplex, how to use multiple of them. Now we know that this 7-segment display basically contains LEDs, and LEDs have an anode and a cathode. Right now, this one is a common cathode 7 display. Okay, so common cathode means it has a common cathode, but anodes, yeah, that is the positive ones, are one for each of the segments. So we connect all of them, fine. And this terminal is basically the common, and we connect this to the negative, to earth. Okay, so we have connected this to earth. So the circuit basically is complete. For example, if I send a signal to A segment, A segment is high, for example. So if this is high, uh, this segment is getting a high, but it's thus the because the electric circuit has to be completed. Completed means from the anode side it is getting a high. On the cathode side it should get a low because the circuit has to complete, because it has to go to earth. It has to go to negative. So if it is complete, it is okay. If it is not complete, then that display will not happen. Now in this example over here, I have actually displayed a 3, only a 3. So I can show you. I'm only displaying a 3. So I'm displaying the third row out of it. And third row is actually a 3. So let me just display a 3. So it basically displays a 3, fine, no problem. Uh, all the proper segments are lit up. Why are they lit up? Because the common is connected to ground. What if I disconnect this from ground? If I disconnect this from ground, what is going to happen? If I start the simulation now, is it going to light up? It is not going to light up. Why? Because the circuit is not complete. All the segments have a common cathode, and the cathode is not connected to ground, so the circuit is not complete. If circuit is not complete, this entire block does not display anything. Let us put, let us use I have removed that wire from here. Okay, so let me just put a switch over here, a switch which basically gives me a high or a low, and I connect this to the ground. What should happen now? When I start, the this resistance is the cathode is not actually connected to the earth because I have not pushed the switch. So when I push the switch, what happens? This glows. When I remove it, it is on. When I switch it on, when I push it, it is on. See what is happening now? The control of this entire block to be displayed is basically dependent on this particular switch. When the switch is on, the block gets displayed. When I push it, when I don't push it, it doesn't get displayed. Uh, this logic should be very clear to you. Number one, let me bring in another block. Okay, so let's start working on the second block now. Okay, so 7 segment. Okay, 7 segment display. I'll bring it here. Let's also make it common cathode. It should be all should be the same. Okay, so please remember, if you're buying these devices and you're buying all common cathode, all common anode, it is okay, but it should not be a mix-up. Otherwise, you'll have to program them differently for each one of them. Now, what do we do? I want to actually replicate the whole thing. Okay, but I will not be um, I will not be connecting all these pins directly to the empty pins over here, empty spaces over here. Okay, what I'll do is I'll connect these to the pins which are already used. So that means I'll connect them to in parallel with the uh, pins which are already being used. So that means B pin of this particular device is connected to B pin of this particular device. So they are connected. Similarly, if I had a third one, its B pin will also be connected to the same B pin over here. That means all the B pins of all the displays would be connected together. So let me connect all of them and I'll get back to you. Okay, all these pins have been connected. Let me start the simulation and see what happens. When I press this switch, because this switch is connected to the cathode of this particular display, so this gets switched on. Why not we create the same kind of a circuit for that also? Okay, so let me make a copy of this particular switch. The switch comes here, it will be directly connected, and the earth of this is connected here. Let me connect it like this. Okay. So when I press the switch, this actually gets connected to the cathode of this. No, it should be here, and this should be here, and this should be okay. So when I start the simulation now, when I press this switch, this display gets switched on. There is a problem with one of the terminals. Yes. Yes. This should be connected here. This is connected to B, A to A and B to B. Let us see. So when I press this switch, there is this displays. When I press this switch, this displays. Now, did you get this idea now? And the idea is these two displays are displaying something, and what is controlling the display is the cathode, the common cathode. When the common cathode gets a low, it actually displays that. So I hope you get this idea now. Okay. Now, what do you see here? If I press this switch, the 3 gets displayed here. When I press this switch, the 3 gets displayed here. But we don't want to display the same numbers on both these things because they are connected in parallel. When they are connected in parallel, what gets displayed here will be displayed here. Let us check that out. Okay. Let me just create a variable here. So I'll create a variable here, which is actually 3. And when I'll change this to C. Okay, let me change all the to C. So what happens now is, let me start the simulation. When I click here, is it a 3? Yeah, it is a 3. Suppose if I change this to a 4, all these will be actually becoming 4. And when I actually display, it will actually display 4 now, but both of them will display 4. So what do we do? Okay, what do we do? How do we display them separately? We display them separately like this. Now, pay attention now. What happens is we display a number, we display a number, and after a delay, we display a number. For example, we have, see, I have, I'm displaying a 4. It displays a 4 here. And after some time, that means after a delay, I change this to a 5 and I switch the other one on now. See what happened when I pressed this switch earlier, it was displaying a 4. And when I display this one now, it is displaying a 5. So that means both of them are displaying different numbers, but at different times. So that means, okay, so what do I do now? I change this back to a 4. I run the simulation again. And when I switch this on, it displays a 4. And when I go back, change this to a 5. I run the simulation again. I press this switch and this displays a 5. See what is happening now? I am What I am going to do through a program is that I am going to keep on changing numbers for both these displays. For one, I will display a 4. For another one, I will display a 5. But when I display a 4 here, I'll switch this on through the program. You know you can do it. And I'll change the system to a 5 now. And then I switch this one on. So this will become a 5. So when this is switched on, this will display a 4. After a delay, this will display a 5. And please remember the delay that I'm talking about is just around 10-20 milliseconds. 10-20 milliseconds is very slow for a computer, but it is very fast for our eyes. Our eyes will see both the numbers because they are happening so fast. The displays are actually displaying them so fast, the 4 and the 5, that our eyes basically don't see that one 4 is switched off and another 5 is switched on, and again that is switched off, again 4 comes on, then and so on and so forth. Our eyes don't come to know. Okay, so what is actually happening? One gets switched on, displays, switched off, again second one is displayed. So let's do that now. I'm going to remove the switches now. I don't need the switches. I don't need this. I don't need this. I don't need this. All right. So this particular block is now going to be connected to pin number 9. So pin number 9 is block 1. And this resistor, in fact this cathode now, is going to be connected to pin number 10. So pin number 9 and 10 are basically going to control whether it gets a low or not. Okay, it gets a low or not. So let's figure out how things are going to happen. Um, let's program them. I don't need this. I'll create a variable called block1 b1 is equal to block1 was number 9 and int b2 is equal to number 10. Okay. And b1 and b2 are going to give output. Okay. So in mode b1 comma output, okay, and pin mode b2 comma both of them are in the output mode. What I'm going to do is I'm going to write, create a copy of this and change C to a 5 and C is a 4. C is a 4. So when C is a 4 here, this will get displayed, and when C is 5, it will get displayed. Let me give a delay of say 50 milliseconds. Again a delay of 50 milliseconds. What I'm going to do is I'm going to digital write in V1. I'm going to write a low because I need a low for a cathode, right? And I'm going to, after that delay, I'm going to give it a high. So when this gets actually, when V1 gets a high, it stops the display of the first block. When it gets a low, it gets displayed. So now I'll say B2 is low, and after the delay, this gets high. Alright, let us see what happens now. Wow, it gets displays 45. So what is the idea behind this now? See, what has happened was that B1, that is the common cathode, common cathode of block 1, display block 1. So it gets a low. You know that a cathode is supposed to get a low. Why? Because the cathode is the negative one. So negative actually is supposed to get a minus voltage. Minus is a low voltage, 0 voltage. So what is going to happen now? Because it writes a digital write B1 comma low. So what happens is this B1, this is actually connected to the cathode, the common cathode of block 1. Block 1 starts, the circuit is complete for block 1. How is the circuit complete? It is getting a high or low from the digits, from the 7 digits. And this is also complete now because this gets a low. So the negative is also complete. So if everything is complete, this starts displaying. After displaying it, after a delay of 50 seconds, it changes B1 to high. So when B1 is changed to high, what is going to happen? When B1 is going to get a high, this is also high, and what the LEDs are getting from the other side is also high. There is no potential difference. So if there is no potential difference, these LEDs stop glowing. And when these LEDs stop glowing, what happens is we make B2 as low. So when B2 is low, B2 low means what? B2 is actually pin number 10, which is connected to block 2, the common cathode of block 2. Now that circuit is complete. The the system is actually sending information from the same blocks, from the same pins, as they are all connected in parallel. So there is no difference between block 2 and block 1. Actually, block 1 and 2 are both getting the same numbers, but our common cathode basically is preventing the other to be displayed. So see what happens. C is now 5. It should now display a 5. So when this gets low, the block 2 is activated now. It displays the number 5 using this entire segments. After a delay of 50 milliseconds, again it goes back. Now again B2 is high. When B2 becomes high, B2 block is switched off. Now B1 is switched on. So this is how things are happening. Shall we try another block? Okay. Shall we try giving it a small delay, a very small delay of 10 milliseconds. Yes, so it is still working. Fine. Let us create another block. Okay, let's create another block. Okay, I have made a copy again. Now I've used pin number 11 for the third block. Let us code the third block also. So we'll have int b3 is equal to 11. So that is using 11, and b3 is in output mode. So let us specify that also. So this is b3, and just write the whole code. Let me copy the whole code for b3. So okay, all right. So suppose I am going to display a 9 on my third block. So I will I will make B3 as low, so that will be activated, and in the end B3 is going to be made as high. Right? So what we are going to do, we are going to display a 4 in the first block, 5 in the second block, 9 in the third block. Let us see if it works. 4, 5 and 9, perfect. So you can see what is happening now. One gets switched on, one gets switched off. All three are not displaying at the same time. They are displaying everything at a delay of 10 milliseconds. But to our eyes, the flicker is not shown. It is not shown as switched off or switched on. It basically, for our eyes, it actually displays at the same time. All right. What if I delay it more? You will see what is happening. I'm delaying it with by half a second. Half a second is enough for our eyes to figure out. See, actually this is happening, but this is happening at a very fast speed. So at a very fast speed means 459 are actually displayed. It appears to our eyes that they are being displayed at the same time. All right. So we know the basics of this display now. We will work in the next uh, video on displaying a clock kind of a thing which has multiple digits, and all the digits will show a time. Okay, not these random 459. It will actually display something useful to us, and there will be at least 4 of these. Okay, so there will be a lot of jumble, lot of these cables running around, but you know that these the connections are basically all parallel, so there is no problem. You just connect one D to another D, another D, and so on. The only rule here is these wires are the controllers. When these get low, that block displays, and after a delay, that another one gets displayed. Okay. I hope you get this idea. Um, I will stop now. If you have any problems, please write comments. Do subscribe to this channel. Okay, and do like this video. Thank you so much for watching. I'll see you in the next video now.